me make some space to explain Euler's, Fermat's. And this space should be enough. Even in your preparation, Fermat should occupy only this much time and space in your preparation. Listen, for number theory, number theorists and mathematicians, Fermat's theorem is amazing, is a big thing. But for us CAT aspirants, it should not take more than this space. And just to tell you, it is called Fermat's little theorem. Fermat's last theorem is a bigger deal. So this is just a little theorem. And what Fermat's theorem says is, I'm stating it, not in the textbook language, not in what you see on the internet. I'm stating it in what is comfortable with students. Okay, and it is, when a power of A is divided by a prime number, when is the remainder 1? I need a remainder 1. We have done enough question to realize why remainder is 1. The moment your remainder is 1, you know the cycle is going to repeat. So when is the remainder 1? When I divide by a prime number. A remainder is 1 when the power is p minus 1. Remember a few conditions. The few conditions are, the divisor has to be prime. Divisor has to be prime. So D has changed to P. And A and P have to be co-prime. There should not be any common factor. Well, actually, if you look at it, a lot of the questions that we did have that same condition. Remember 213, they don't have anything in common. They are co-prime. 13 is prime, 13 is prime, 13 is co-prime to 199, 17 is co-prime to 195, right? So basically, from your point of view, try to think reverse. You want a remainder 1, you are dividing by a prime number. What should be the power? The power should be A raised to P minus 1. That's it. This is your Fermat theorem. So you might say, oh, that gives me an immediate answer to my cycle. Cycle is of how many values? Hang on. It's not so very straight. So let's take the first question here. The divisor is 30, 5 raised to 199 divided by 30. Yes, 5 raised to 12 divided by 13 will leave a remainder of 1. This is what Fermat's little theorem states. The divisor is prime 13, 13 minus 1, 5 raised to 12. So you might end up at 5 raised to 12 would give a remainder 1. Yes, and now every 12th will give you a remainder 1. So 5 raised to 12 raised to anything will also give you a remainder 1. 1 raised to anything is 1. So you need the 199th term. So I would go to 199th term. You would do 199 divided by 12. Why 12? Because at 12 it becomes 1. 12 ones are 12, 79, 12 6s are 72. So this will give me a remainder of 7. Oh, unfortunately, 199 is not a multiple of 12. You have a remainder of 7. So that is going to be the 7th in the cycle, 7th term of the cycle. Now you don't have any cycle with you. If you do Fermat's theorem, the only thing that you know is, at what power am I going to get 1? So I know at 5 raised to 12 I am going to get 1, but I want the 5 raised to 7. Now I don't know 5 raised to 7, and if you want to find 5 raised to 7, if you go back and start doing 5 raised to 1, 5 square, 5 cube and so on, then why did we not do it in the first place itself? So I don't think so it's going to help us too much. On the other hand, if you look out over here, the cycle is made up of how many terms? The cycle is only made up of 4 terms. 1, 2, 3, 4. Whereas this tells you 5 raised to 12. Remember, 12 is, there are no 12 different values of divisors. Right? It is just that at 5 raised to 12 it will be 1. Will it be? Let's see, at 5 raised to 4 you get 1. At 5 raised to 8 you will get 1. At 5 raised to 12 also you will get 1. But it's not going to help us any which way. Again, just to continue and tell you, let's do the next question. at least it will satisfy your curiosity and you'll understand it's not worth chasing it. So in the second question, 199 we reduced it to 4 raised to 200 divided by 30. So divisor is prime. So all I know is 4 raised to 12 divided by 13. The remainder is going to be 1. Good. And I need to find the 200th term. 200th term. The only way format would have been useful is if this was a multiple of 12. If this was a multiple of 12, you could say I want a multiple of 12th term. 12th will give you 1. I again repeat, raised to anything. 4 raised to 12 will give you 1. 4 raised to 24 will give you 1. 4 raised to 36 will give you 1. 4 raised to 120 will give you 1. 4 raised to, let me go closer to this. What's a multiple of 12 close to this? A multiple of 12 close to this is going to be 180, 192. 192. 4 raised to 192 will also give you remainder 1. But the question is not asking you 4 raised to 192. After 192, what will it be? Add a 12 to it, you will get 2012, 202, 204. Is it? Yes. 4 raised to 204 will also, let me confirm it. 12 ones are 12. Yes. 4 raised to 204 will also give you remainder 1. But the question is not a multiple of 12. Right? So, you would again have to do 200 divided by 12 and the remainder would have been 12 ones are 12, 80 left over. I'm making a mistake, 12 ones are 12. I'm not making a mistake. 12 ones are 12, 80 left over. 12 6 are 72, the remainder is 8. So this is going to be same as the 8th term. Yeah, I'm not making any mistake. 192nd term is where the cycle ends. 200 will be the 8th term from then onwards, right? But then I do not know these values. So what is the point? How do I find what is the next term? What is the 8th term? For that you would have to find the cycle. If you had to find the cycle, you could have done it right at the beginning itself. And I would again want to point you out to you. This says 4 raised to 12 is going to give us 1. But the cycle is made up of only 6 values. Right? Yes. If the 6th value in a cycle is 1, then the 12th value will also be 1. But that doesn't help me as much. Right? You want, I can continue this. But then I again tell you, should you be aware? Yes. But having seen so much of enthusiasm, I've read this and I know. So the moment I start this, I know there is 13. So I know raised to 12 will give me 1. So I'm comfortable that by 12 I'm going to get my answer. Right? And it is going to be a factor of 12 only. So here I have seen 17. You are dividing by 17. 17 is prime. So number raised to 16. A co-prime number, obviously a co-prime number raised to 16 will give you a remainder 1. If 16 gives me a remainder 1, where else can I get a remainder 1? I can get a remainder 1 at the 8th position also. So is this at the 8th position? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I have an idea either at the 16th or at the 8th or at the 4th or at any factor of 16. But then we don't really think that students need to be aware of so many things. Just write your cycle, it's going to save your day. If the values is tougher, it's anyways going to save your day. If the value is easy, even the cycle is going to turn out to be very easy. So this is Fermat's theorem. Students go further and even learn Euler's theorem. Euler's theorem is even I'll choose my words carefully. Euler's theorem is of no value as far as CAT preparation goes. Okay, so I'll introduce Euler's at the appropriate moment.